Good morning, students. Today I will explain about kinetic theory of gases. In this particular chapter, we can know when what are the general properties of gases, what are inside the gases, and when heat energy is supplied to the gas, what are the changes the gas may have. All these factors we can discuss in the topic kinetic theory of gases. And when it comes to gases, here we have and we mention two important names or two important types of gases. One is ideal gas, other is real gas. Ideal gas and real gas. From the name only you can understand here that ideal gas means some ideal properties are to be defined, and based on that we imagine a type of gas called ideal gas, and other all practically whatever the gases we have, those are said to be real gases. And fundamentally we should know here the basic difference between ideal gases and real gases. The properties, ideal properties, are simple properties given for ideal gases. So these properties are called as assumptions of kinetic theory of gases. According to that, in every particular gas, there are some small and tiny particles. What are inside the gas? We imagine here that in every gas there are small tiny particles which move randomly in all the directions. They won't stay at one particular point. They continuously move in all the directions. For example, if I consider this is a container having some gas inside it. So in this particular container, there are some small particles, small in the sense when compared to the size of the container, and when compared to the distance between the two such particles, so the size is very, very less, and the size is also negligible. Such small particles are called as molecules. Okay, every gas contains large number of identical tiny particles called molecules. Of course, we should know here one more point that these molecules have different properties for different gases. And of course, at different pressures, different temperatures, different volumes. These three properties, pressure, volume, and temperature, these three properties we mention for any particular gas to explain the state of that particular gas. So first of all, some identical particles are taken here which are called molecules in specific gas. But I already mentioned that these are the assumptions of kinetic theory of gases. These are all not applicable for real gases. Some of them may be applicable, but all properties are not applicable for real gases. These are the properties taken for ideal gases. Only these are assumptions that should know that you should know. And the size of molecule is much smaller than the average separation between the molecules. That's what I mentioned here. And what do these molecules, what these molecules do inside the gas? They always move randomly in all possible directions. We cannot say that they move along exactly one molecule exactly moves only along x-axis, only along y-axis. In that way we cannot mention here, because these molecules move randomly in all possible directions. 360 degrees లో ఎటువైపైనా వెళ్ళొచ్చు, అది అన్ని పాసిబుల్ డైరెక్షన్స్ లోనే వెళ్తుంది అది. Okay, and also they may have any speed. All these molecules may have different speeds. The speeds may be there between 0 and infinity. Any speed the molecules may have. 0 meter per second, that means rest only. 1 meter per second, 2 meter per second, 100 meter per second, 1000 meter per second. Any amount of speed these molecules may have. And next one, while the molecules are moving, what will happen to the molecules? Definitely there is a fixed volume only. There is some fixed container we have taken here. So whenever such limited space is taken, while the molecules are moving, what will happen? They cannot move continuously to infinite distances. So while they are moving, definitely they undergo some collisions. The collisions may be in between the molecules, and also there will be the collisions between one molecule and container of the gas. Both may be happen. ఒక మాలిక్యూల్ వెళ్ళి ఇంకో మాలిక్యూల్ తో కొలైడ్ అవ్వచ్చు, లేదంటే వాల్ ఆఫ్ ద కంటైనర్ తో కూడా కొలైడ్ అవ్వచ్చు. అండ్ ఆల్ దీస్ కొలిజన్స్ ఆర్ టు బి టేకెన్ యాజ్ ఎలాస్టిక్ కొలిజన్స్. ఎలాస్టిక్ కొలిజన్స్ మీన్స్ where it satisfies both conservation of momentum and conservation of energy. But energy transfer we don't consider in these type of ideal gases. Only the change in momentum we calculate here. But all these collisions are what type of collisions we can consider? That is exactly elastic collisions. These collisions are elastic collisions. And in case of real gases, when it comes to real gases, the collisions are not elastic. The collisions are non-elastic collisions. Maybe different types will be there, but they are not elastic collisions. And whenever one molecule is moving from this point to this point, and this molecule may come like this. For example, I consider here both the molecules are collided. When both the molecules are collided here, after collision, this molecule will go in other direction, this molecule may go in this particular direction. ఇది ఎలా వచ్చిన తర్వాత it may collide with another molecule here. These two molecules may collide. Then after collision, this molecule may collide with any other molecule, or maybe it may be collided with wall of the container. In such a way, every molecule undergoes many number of collisions. And you should know here that the between any two successive collisions, for example, this molecule collides with this particle here, collides with this particle somewhere here, and maybe it may have some collision with wall of the container somewhere here. In all these cases, can you expect that it travels same distance between two successive collisions? No, not possible. In one collision, it may travel more distance. For other collision, it may travel less distance only. So that always the distance traveled between any two successive collisions is not same. Always the number changes. But if you consider from probability conditions, if you calculate average distance throughout the collisions by a molecule between two successive collisions is called mean free path. So that is said to be mean free path. Really, we cannot see the molecules, even with microscope also. Even when the molecules are moving like that, they undergo number of collisions. They may have speeds of nearly 10 power 3, 10 power 4 meter per second speeds also they may have. With that much speeds, the molecules are moving for less distances. We cannot identify them. Even then, we can calculate here mean free path only by using probability calculations. అంతే తప్ప దాన్ని చూసి మనం ఎలా మూవ్ అవుతుందో చూసి మనం మెజర్ చేయట్లేదమ్మా. Only by using probability calculations we can calculate that what is that average distance called. Average distance is called mean free path. These are the basic properties we considered for ideal gases. That's why we called it as assumptions. Okay, now what are the other properties of ideal gases? Some basic information about ideal gases. When it comes to particularly ideal gas, for example, if I consider one particular container here also, in real cases, all the molecules existed in case of real gas. All of them will have some interactions between them. That means one molecule and other molecule are attracted, and they are attracted towards each other, and they may undergo some collisions. So whenever there is an attractive force, you can understand that there is some potential energy between the molecules. This will happen in case of real gases. In case of real gases, what will happen? Because of attractive forces between the molecules, so definitely there is some potential energy between the molecules. And of course, while they are moving, they will have kinetic energy. But when it comes to ideal gases, there is a condition for the ideal gases, that the molecules of ideal gas should be at large separation in such a way that there should not be any interaction between any two molecules of ideal gas. If ideal gas is taken, between any two molecules of ideal gas, there should not be any interaction. But why should they undergo some collisions then? Even they don't have an interaction. Randomly they move with some kinetic energy only. They never have potential energy between them. They never have interaction between them. But randomly while they are moving, they may undergo some collisions. But we should not say that because of attractive forces they undergo some collision. Only random ga move avutu ekkado oka chota collision jarige chance matrame untundi. This is ideal gas. These properties I mentioned for ideal gas, but in real gases what I mentioned, it is not like that in real gases. In case of real gases, all the molecules have some interactive forces. Because of interactive forces, there are some collisions. So real gas concept is very complicated, and it is also not needed here. Completely we won't discuss much about real gases in this particular chapter. In this particular chapter we discuss only about ideal gases. So when it comes to ideal gases, what is the first property? The molecules of ideal gas have large separation and they do not have any interaction between them. And the size is negligible only. The size of molecule is negligible when compared with the distances traveled by the molecules. So we don't give a definite volume also for that particular ideal gas. For ideal gas we never give some definite volume. And existence of ideal gases are possible when you want to convert, or when you want to get some properties of real gases, properties of ideal gases from real gases. If you are expecting, then it may be possible only at very high temperature and low pressure. Why at high temperature? When temperature increases for the gas, what will happen? The molecules will get more and more separation. Whenever the molecules are get separated, then when they get more separation, it may satisfy the properties of ideal gases na? So it is possible at very large temperatures, whenever they are moving apart from each other, whenever they have more separation, we can say that the pressure is very, very low. In such cases, it is possible to get ideal properties for real gases. But already I mentioned that in this particular chapter, we mostly learn about only ideal gas, not about real gases. Now, when it comes to ideal gas and equation part of ideal gas, so let me take here what are the different properties we mentioned for to represent the state of any gas. I mentioned that we represent three properties. One is pressure, other is volume, and the third one is temperature. For any particular gas, we need to represent these three quantities to explain the state of the system. What are the three? Pressure, volume, and temperature. And for any particular ideal gas, I think all of you know about Boyle's law and Charles' law. From that particular law only we can write this. But here you can simply write here that PV is proportional to temperature. The product of pressure into volume is directly proportional to temperature. Then what we can write here? PV equal to some constant into temperature. And this formula we have written only for one particular molecule of gas. I have written this formula for one particular molecule only. Then this constant K is said to be Boltzmann constant. What is that constant called? Boltzmann constant if it is taken for, if a gas is taken for one molecule. So Kb is equal to, that is 1.38 into 10 power minus 23 joule per Kelvin. This is the value of Boltzmann constant. And in this particular case, if I consider more number of molecules, for example, if I consider n number of molecules in a gas, now I will write the formula here. if I consider n number of molecules into Boltzmann constant into T, temperature. This is the formula you can write. But the same formula we can explain in other terms also. But in case of gas, whenever if you want to give the number of molecules in a gas, mostly we mention in terms of Avogadro number. What is Avogadro number? 6.023 into 10 power 23. So whenever there is that many number of molecules in a one particular gas, that is said to be 1 mole of gas. The number of molecules in 1 mole of gas is said to be Avogadro number. So if you want to write in terms of Avogadro number, and if I consider only 1 mole of gas here, what we can mention here, that is Avogadro number only, na? What is the Avogadro number value? Avogadro number is nothing but 6.023 into 10 power 23 per mole. That many number of molecules per mole. Now this is equal to PV equal to what is Avogadro number into Boltzmann constant. This was taken for 1 mole only, na? This was taken for only 1 mole. Avogadro number is 6.023 into 10 power 23 and Boltzmann constant is 1.38 into 10 power minus 23. By multiplying these two numbers, of course 10 power plus 23 into 10 power minus 23 becomes 1, and 1.38 into 6.023 is nearly equal to 8.314 into temperature. This value 8.314 is nothing but universal gas constant. This number is said to be universal gas constant. So PV can be written as RT. This is also equation for 1 mole. For 1 mole of gas, what we can write? PV equal to RT. But if I consider more number of moles of gas, if the gas contains more number of moles, what we write here? PV equal to how many number of moles are taken. For example, n number of moles are taken. In general, we indicate small n for number of moles and capital N for number of molecules. So nRT. Finally, what is the general equation we can give for ideal gas? Ideal gas equation is nothing but PV equal to nRT. Okay. Now, when it comes to real gases, the equation I will write here. Which equation the real gases follow, that I will write here.